Go and open your book to page 317. Today's lesson is, again, to analyze the quadratic functions and know how to draw its graph and find the minimum and maximum. Okay? So it seems like a lot of stuff, but it's very similar to what we did in the previous lesson. So first, it will help if you go and sketch. And in the previous lesson, to sketch, you have y minus k equal to a times x minus h squared, right? And so when you're going to graph this, you get a vertex, right? And the vertex would be h and k, right? And then from here, and then you can use the a, so you can go and do the graph from there, right? So first you plot the vertex, and you go 1 over up 1, right? 3, 5, right? But now in this lesson, you don't have this nice complete square equation. So you have f of x. Now f of x is same as y. It just gives you more information. So you got y is equal to ax squared plus bx plus c. So instead of have this equation, you have this type of this kind of equation right now. Okay, the function. So how are you going to find the vertex? Because again, when you're going to graph, you still need to get vertex, right? Once you get a vertex, then you have the a. You can do the same thing, right? So one technique is you can go and complete a square, but usually this takes too long. So there's a faster way to do this. Okay. So by using just like how we derive the quadratic formula, right? By completing a square, so you can do the same thing. But by doing the same thing and you solve, right? The vertex, the coordinate for vertex in this format is not h and k anymore. The vertex would be, it's going to be negative b over 2a and negative b squared minus 4ac over 4a. Now this kind of came from the quadratic formula because remember what I said, right? To get from here to here, you complete a square and you solve, right? So notice the quadratic formula is x equal to negative b plus or minus square root of b squared minus 4ac, right? Over 2a, right? So remember, vertex is your double root, right? Remember, double vertex, when you graph this, it's like this, right? So the vertex over here, this is like your double root. So that is when this is equal to 0. So that's where this came from. Everybody see that? Okay? So again, vertex is when it's double root, means you only get one answer. And that is when this is equal to 0. So that's where this came from. Okay? So negative b over 2a is from here. Okay? And this one, after you find the vertex coordinate is negative b over 2a, you substitute this back into x and you get that. Okay? And you kind of notice that it's kind of very similar to this, right? There's some similarity to that, right? Now, instead of trying to memorize both this is kind of hard to memorize. So my suggestion is that it's just going to memorize this part over here, and then after you solve for the h, you substitute back in here, and you can find the k. So let's go over some examples. How does this work? Okay. So let's go to example 2. On page 318. So again, everything you're going to do exactly what you do with last time, okay? Except the technique is a bit different to find the h and k. So once you find h and k, you'll be just like the previous assignment, okay? The previous lesson. So on page 318, you got g of x. Now g of x is just the name of the function, right? Just like like washing machine, dryer, right? All those are functions with different names, right? For different things you would do. So g of x. Now I'm going to rewrite the function so that it will arrange in a nice order. So g of x equal to negative 3x squared plus 6x plus 6. Okay? So a equal to negative 3, b equal to 6. So my h over here, so my h is equal to negative b over 2a, and h is equal to negative 6 over 2 times 3. So my h is equal to 1, negative. Okay? oh, A is negative 3, yeah, sorry about that. Yeah, right. Okay. Okay, so your H is equal to 1. So now once you find H, to find K, you just substitute back in here, okay? So H is your spatial X, right? So K equal to negative 3 times 1 squared plus 6 times 1 plus 6, right? You just substitute into here, right? So again, H is a spatial X. K is a spatial Y, okay? And so you work it out. So K equal to negative 3 plus 6 plus 6. So K equal to 9. Okay? So your vertex is going to be at 1, 9. Okay? Okay, so your vertex will be 1, 9. So it's just a different format, different form. We have different technique of getting your H and K. So once you do that, when you graph, right? If you're going to graph, so it's 1, 9. So 1. So it will be 1, 9, right? Vertex over here, right? Now your A is negative 3, right? So when you're doing the graphing, you know the 1, 3, 5, right? So A equal to negative 3, so it will be negative 3, negative 9, negative 15, right? So you go over 1, you go down 3, right? Over here. And you go over 1, you have to go down 9. Okay? So it's going to go like this. And it's negative, that's why it's upside down, right? And you go over 1, over here, go over 1, over here. So your graph's going to be like this. Okay? So again, same as what we did last time, except you have different way of finding your vertex. Okay? So that's how you sketch your graph. Again, you use the H equal to negative B over 2A, find the H, substitute back in the original equation, you get K. That way you don't have to memorize this mess over here, right? This is kind of hard to memorize. And if you memorize it wrong, then your answer is going to come around and mess everything up, right? Okay, so again, once you find your vertex, you put it over here, and remember your A, right? A is from here. So there, the A is the negative 3, so you get the differentials, and you can sketch that. Then after that, you want to find all the other stuff, okay? So over here, they want you to find the domain. Domain means the value of x. What kind of x are you allowed to have? Well, in this case, there's no restriction, right? So the graph goes on forever. So x can expand in both directions. So in this case, would be all real number, right? Okay. B, you're looking for the range. The range is value of y. So in this case, if you look at the graph, so y had to be less than or equal to 9, right? So if you look at the graph, right? So you look at graph. So y, the maximum is 9. So you have to be less. It keeps going down. So it'll be less than or equal to 9. Okay, so that's the range. And then you have to find the zeros. So zeros is where it crosses over. So here are your zeros. Zeros is when y equal to 0. Okay. So in this case, your zeros would be x equal to negative 1 and 3. Okay, those are your zeros. So again, and this, so there are several important points. Okay, so this is called vertex, right? So make sure you know the important features. This is your y-intercept. Okay, so that's your y-intercept. This is called your zeros or x-intercept. They are the same thing. Okay, so zeros or x-intercept. So make sure you're familiar with all the terms. Okay, so that's what you have to do, and that's it. Okay. Now, if the graph is upside down, you're going to get maximum. If the graph is going up, then you get minimum. So in this case, if they ask you for minimum or maximum, okay, they didn't ask you to do it. But let's say if they ask you to do it, so D, if they ask you for minimum or maximum, in this case, you get a maximum. So in this case, you're going to get maximum, and maximum will equal to, well, maximum would be y equal to 9, right? Or just 9. Okay. So you can do either way. Let's just do maximum equal to 9. Normally they just ask you for value. So maximum equal to 9. Okay. Okay. So when you if you don't ask you to graph, then you don't have to graph, and you can just set. So let's go to page 320 on your assignment. Okay, so let's look at number 2. Okay, now it says rewrite each equation in the form y minus k equal to a times x minus h squared. Use a method shown in example 1. Sketch the graph and show the coordinate of the vertex and the point where it crosses the y-axis. So now look for zeros. Okay, so just like the one we just did. So you have y equal to x squared plus 4x plus 1, right? So they want you to write it in this form. They want you to write it y minus k equal to a times x minus h squared. So that means, yeah, a couple ways you can do this. If you do it a long way, you have to complete a square. Okay. Now, if you do it the short way, you don't have to do the complete a square. Okay. If you do the complete a square, this is what you need to do. Okay. So again, don't do this. Okay. I'm going to do it the long way. So don't do this. Okay. So let's say if you're doing it a long way, so you have to complete a square to get that, right? So first you have to vacate a number. So you got y minus 1 equal to x squared plus 4x, right? Vacate a number. So then you got y minus 1 equal to parentheses square. So you have to figure out what number goes up here. So from here you're going to get x, from here you get plus 2, right? And so the number that you're missing is you need to plus 4, right? To get a perfect square, right? Now because you plus 4 over here, you need to plus 4. So you have to, so don't write this first. So you need to write, so this becomes plus 3. Okay? So your equation becomes y plus 3 equal to, so that's how you complete a square. And then from there you go on, right? But the problem with complete a square is it gets messy when you get to like number 12, for example, or like number 10, right? So another way to do this is I can use your negative b over 2a. So a equal to 1, b equal to 4. So h equal to negative b over 2a. So h equal to negative 4 over 2. So h equal to negative 2. Okay? And then from there you get your k. So k equal to negative 2 squared plus 4 times negative 2 plus 1. So k equal to 4 minus a plus 1. So k equal to negative 3. So once you know your h and k, then your equation becomes y plus 3 equal to, and we know that a is 1, right? So it'd be x plus 2 squared, right? So you end up with the same answer, right? So notice in this case, because equation is simpler, then you can do the complete square if you want to. So you can use either method. So you kind of have to look at the equation. If it looks kind of hard to complete a square, then especially if the a is not equal to 1. If a equal to some number, then it's easier if you do it this way. But if a equal to 1, usually complete a square is fairly easy. So you can do it either way. Okay, you should get the same answer. But the bottom line is you need to go and get this equation. So from here, they want you to sketch. So again, when you sketch, negative 2, negative 3, that's the h, right? And the a is positive, so it's 1, so you just go over 1, go up 1, go over 1, you go up 3, right? And 5, right? So your graph is going to look something like this, right? Okay, so that's going to make sure you go back and forth to answer all the questions, right? So sketch the graph, okay, did that? Show the coordinate of the vertex, okay, so vertex is negative 2, negative 3, right? And the point where it crosses over the y-axis, so they're looking for the y-intercept. So the y-intercept would be 0, 1, okay? And again, check, make sure everything, you did everything, okay, so that's it, okay? Now, when you get to things like number, for example, if you get to number 20, okay. Now the number 20, it does not ask you for the graphing, but this one you still have to do the graphing, okay? Because you need to know you have to look at the graph to see the range, right? Okay. But sometimes some of the point is fairly easy. You can just do it without graphing, okay? So again, there are many techniques you can do this. So let's go and go over 20. So g of x equal to negative x squared minus 2x plus 8. So this one, you're looking for the domain, you're looking for the range, and you're looking for the zeros. Okay. So for domain, right away, since it's quadratic, you know the graphs is going forever, right? So we know that it's going to be all real number. Okay, so without even how to do anything, we know it's going to be all real number. Now the range, we need to know where the vertex is. Okay, so the vertex, again, there are a couple ways you can do this. You can graph that and look at the graph to find out the range, or all you need is the vertex. So the vertex, okay, over here, so a equal to negative 1, b equal to negative 2, so h equal to negative b over 2a, so h equal to negative 1, yeah, 3, okay. Then k equal to negative 1 squared minus 2 times negative 1 plus 8, right? I just substitute this into x, to find y, right? So it's going to be negative 1 plus 2 plus 8, so k equal to 9. Okay. Now, once you do this, right? Then what you want to do next is your vertex would be negative 1, 9. So if you sketch your graph, yeah, they don't ask you the graphs, but so you can just go and sketch. So this, because a is negative, it's going to be like this, and this point over here is going to be negative 1, 9. So from here you can see the range is y had to be less than or equal to 9, right? Because it's negative, so it's going to go down. So you can maximum. So y would be less than or equal to 9. Okay. Now to find z, again, there are many ways you can do this. One, if you sketch it out, right, and use over 1 up 1 over 1 up 3, right, then you can look at the graph. But if you didn't look at it, let's say if you didn't do the graph like over here, then to find z, the zeros, you set this equal to 0. Okay, so you set this equal to 0. That's why I call it 0, right? You set this equal to 0. And I don't like the negative. I'm going to multiply it by negative 1. Okay, and I'm going to do the factoring. So x plus 4, x minus 2. So you're going to get x equal to negative 4, x equal to 2. So those are your zeros. So negative 4 and 2. Okay. So again, if you graph it out, you're going to see where those two zeros are. It's going to be at negative 4 and 2. Okay. So again, there are many ways. So what you want to do is try to kind of see how all different methods kind of link together. Okay. Okay, so let's go ahead and do practice.